So in lesson 4, we're looking at linear inequalities. We're going to look at how to solve them, how to represent our answers on a number line and with our notation that we were talking about in that last lesson. And we're also going to talk about how they don't necessarily just give us one solution, like what we're used to. Sometimes they can give us lots of solutions, and sometimes we need to figure out in what range our solutions actually lie. So they're a little bit trickier than just solving a regular equation. So first of all, what we want to do if we're solving linear inequalities, what we want to do is move all variables to one side of the inequality, pretty much the same as what we always do, try and isolate that variable. And then we want to express our answer in interval notation. There's one thing to remember that's a little bit different with inequalities rather than just regular equations. If you multiply or divide both sides by a negative number, you have to reverse the inequality. So that means if it was a greater than sign, it would now have to become a less than sign. And that's something you learned a long time ago, but may have forgotten. So it says for an inequality, there may be an infinite number of solutions. And that's why sometimes we show our solutions on a number line. So let's just try and solve this one first of all. So obviously we're just going to add 2 to both sides here. 8x is less than or equal to, 9 plus 2 is 11. And then we can say I'm going to divide both sides by 8. And so x is going to be less than or equal to 11 over 8. So this is important. This is part of our solution. But what we want to do is represent this in a couple of different ways. So first of all, on a number line, which we just practiced in that last lesson, if I've got 11 over 8, I know that x is less than or equal to that. Because it can be equal to, I've got my closed circle, and less than would go in that direction. And then we can represent that with our open bracket, negative infinity up to 11 over 8 with our closed bracket. Next one is really similar. I'll just kind of do this one quickly. Minus 4, minus 4. So we've got 3x is greater than negative 2. X is going to be greater than negative 2 over 3. So on the number line, negative 2 over 3, x is greater than, so we have an open circle, and our solution would look like this. Again, open circle for 2 over 3, and then that would go up to positive infinity, again with an open circle. Pretty straightforward so far. Next one is, instead of just linear inequalities, which you can see here, I'll just go back for 1 second, all of these just have x to the power of 1. Now we're going to get into a little bit trickier, where now we've got quadratic. So obviously x is going to be to the power of 2. It's saying here, solve each of the following quadratic inequalities, state the solution using interval notation. So that's with our brackets that we were talking about. What we want to do is pretty much basically the same thing as what we were doing. So just going to start off here. If you wanted to solve this, if you just even imagine that there was an equal sign there, we know that we would have to factor in order to do that. And this is obviously in the PSA 1. So I'm looking for the factors of negative 15 that add to give me negative 2. So that's going to be negative 5 and positive 3. So if I write that out, x minus 5, x plus 3, is less than 0. This is where we kind of run into some difficulty, where we say, okay, what does that mean? Well, we know that normally x is equal to 5 and negative 3, which is right, but because that's an inequality, we actually have to do some test intervals to figure out where is our inequality. Is it greater than 5? Is it less than 5? Negative 3? What's going on there? So if we kind of look at our steps here, so move everything to one side of the inequality, factor the expression, state the critical values. These guys here are my critical values. And then the next step is do an interval test. Test each region defined by the critical values. So what we want to do is kind of identify this on a number line for ourselves. So negative 3 and positive 5. And you can see that we've got 3 little sections here. And what we need to decide is in what section is this solution actually going to work. So for instance, if I look at section number 1, okay, I need to choose a number that is less than negative 3. So we could choose whatever, negative 5. Okay. If I choose, I should say x is equal, if I choose x is equal to negative 5, now what I can do is plug that back into my original equation. So I've now got negative 5 squared minus 2 times negative 5 minus 15. And that's going to give me 20. And I want to see, is that less than 0? Well, it's not less than 0. So therefore, this is not a solution. So my solution set doesn't go there. Second one, let's choose a number that's in between negative 3 and positive 5. Well, a nice easy one would obviously be x is equal to 0. So now let's plug that in. I've got 0 squared minus 2 times 0 minus 15. And if I multiply all that out and simplify, I'm going to get negative 15. Is that less than 0? Yes. So that means that this is part of my solution. Next interval is 3. I want to choose a number that's higher than 5. So let's say x is equal to 10. Again, it can be whatever you guys want. Now I have 10 squared minus 2 times 10 minus 15. And when I actually evaluate that, that's going to be 65. Is that less than 0? No. So that is not my solution set. So how would I represent this? Well, I know that that section number 2 is my only solution. And because I've got less than, that automatically tells me that I've got open circles at these guys because it cannot be equal to those points. So I have my open circles there, and then I'm going to know that my solution lies in between those guys. So if I wanted to actually give my solution, it would be an open circle at negative 3 up to, an open bracket from negative 3 up to an open bracket at positive 5. And that would be our solution, solving that as an inequality. Another way, just to give you guys a little bit of a heads up, if you're a really visual learner and you really liked graphing, you could actually cut out 3/4 of this work. If I look at my graph of this, and I'm not going to do this every time, but just to kind of give you guys the heads up that you could have also done this in your head. So positive 5 and negative 3, I know that 2, 3, I have a point here, 1, 2, 3, 4, 5, I have a point here. This is a quadratic, so I know that this is going to be a happy face graph. Okay, and we're looking to see where is my graph less than 0. Well, obviously less than 0 is going to be all in this section, which is exactly the same as this. It's in between negative 3 and positive 5. So again, just a really visual way of seeing your solution, and definitely a lot quicker than doing those test intervals. So if we take a look at one more example of doing this, if I look here, I'm just going to get rid of this work for us. So for B, first thing, obviously, we want to set everything equal to 0. So we're going to move everything over. Minus x minus 6 is greater than 0. Again, we're going to have to factor this guy. So we know the factors of this that add to negative 1, going to be negative 3 and positive 2. So x minus 3, x plus 2, greater than 0. And we know that x is going to be equal to positive 3 and negative 2. Again, we don't know where the solution is, but we can definitely look at these points and at each section. Now I'm going to be lazy in this one because I've already shown you the test intervals, and we are going to do some more test intervals on the next page. So we're just going to look at the graph of this because I think that's pretty logical at this stage in the game. So if I look at the graph of this guy, I know that negative 2 and positive 3, we know that this is again a happy face graph because x squared is positive. I'm looking like this and this. And we're now looking to see where is my graph greater than 0. Here and here. So that solution, again, we're using open circles because of this greater than. There's no equal to. And we know that the solution would be this way from the 2. It would be left. Anything less than negative 2. And then obviously with the 3, it would be anything to the right of that. So our solution would look like this. Again, if you don't like this method, if you're like, nah, I don't really like graphing, don't forget that test interval. And if you forget how to do it, like I said, we'll do that on the next page. How will I represent this in my intervals? Well, this is negative infinity up to negative 2, open brackets for everything. Remember, there's 2 solutions, so I have to use that union thing that we talked about before. 3, and then all the way up to infinity. And that would be our solution. All right, so let's practice a little bit trickier. This is getting more into the stuff you guys are going to be seeing. So rational inequalities, obviously we're bringing in some fractions here. Now, again, we're pretty much solving the exact same way. You just almost imagine that the inequality isn't there, that it's just an equal sign. So again, we can go through the steps, solve using the critical values, find any non-permissible values, find the solutions. We can read through all that, but I think it's just going to make more sense if we kind of all do it together. Now, right away, what you're going to notice, I did mention non-permissible values. Now, that is always a real gimme. That's automatically going to give us a critical value. And remember, we find that from our denominator, because our denominator can never equal 0. So in this case, x can never be equal to 1, because 1 minus 1 would be 0, and we can't have that. So that actually is our first critical value. So we can literally put that right on our number line. We already know that that's going to be on there. Now what we want to do is solve for x. Now, remember I said we just imagine basically that that's an equal sign and not a less than sign. And what we can do is just cross multiply here. So x plus 3 is less than, or basically we're assuming it's just kind of like equal to, and then that times that, so that would become 2x minus 2. And now we can combine, so I'm just going to like minus x plus 2, just kind of bring everything over to one side. So that's going to be 5 is less than x. So obviously 5 has to be a critical value, because again, we're solving for that. Now in this case, the graph is not something that you guys can be like, oh, it's a nice parabola, or oh, it's going to look like this. This one's quite a bit trickier. And remember in calculus that there is not a stress on using your graphing calculator. In fact, we kind of say don't use your graphing calculator, because obviously your teachers probably mentioned to you already this semester that it's not allowed in university, or it wasn't at the time I was making this podcast. So you just want to be careful. Don't depend on it. So this is where our test intervals are going to come in. I'm just going to erase this. And test intervals, I will admit, can get a little bit long, but it's basic math. And it is actually quite important for you to do. And there are other methods. There is a table method that your teacher might be showing you as well. And that's a great way to do a test interval too. So this will be like method 1, and your teacher may show you a different one, and that can just be method 2. So test intervals, let's try first of all number 1. So we want a number that is in that range, a number that's less than 0. Well, why don't we choose again x is equal to 0? Sorry, we want a number that is less than 1. So why don't we choose x is equal to 0? That makes sense to choose something easy. So we're going to put 0 plus 3 over 0 minus 1. Is that less than 2? Well, I've got 3 over negative 1 is less than 2. Well, 3 divided by negative 1 is negative 3 is less than 2. So this is going to be a solution. Second one, I'm going to kind of run out of room here. But I want to look for a number again now that's in section 2, which is in between 1 and 5. So that would be x is equal to 2, let's say, for instance. Or you could have chosen 3 or 4 or whatever. So now I'm going to put that in. So I've got 2 plus 3 over 2 minus 1. Is that less than 2? Well, I've got 5 over 1 is less than 2. No, that's not going to be a solution. So therefore, I can just put an x in that section. And then the last section, anything that's over 5. So again, I just like to choose 10. Choose whatever you want. 10 plus 3 over 10 minus 1 is less than 2. So I've got 13 over 9 is less than 2. And yes, that absolutely is less than 2. So we know that that is also going to be a solution. So once we're done with those test intervals, which again, I realize can be a bit of a pain. Now I just want to draw out my solution. Now remember, I'm looking at less than, so any circles that I have to be open circles. So a circle here and a circle here, and I know my solution is going this way and it's going this way. And now we can represent our answer negative infinity up to 1, all open brackets, sorry, union, again, 5 up to infinity with open brackets. And that's going to be our solution. I'll do one more. Again, I really encourage you to probably pause this, do this next one yourself, and then just double check and make sure that you're kind of getting the same answer. So this one, again, we want to look for our non-permissible value. So right away we know x cannot be equal to 5, and that's something that we can put right on our number line. Next, we can solve, same as what we did before, cross multiply. So I've got 2x squared plus x less than or equal to 3x squared minus 15x. And now we can bring everything over. So I'm going to take that over there, bring that over there. So I've got 16x less than or equal to x squared. And remember, we want to kind of bring everything to one side. We want to be able to factor. So probably what I would do is bring that one back over. And we've got 0 less than or equal to x squared minus 16x. And this we can obviously factor out an x. And then we've got two solutions here. I've got x is equal to 0 and 16, because remember, we're solving this just like an equation. So we've actually got now more sections which equal more test intervals. Woohoo! So we've got 1 over here, 2, 3, and 4. So these test intervals, let's start off with number 1. I need a number that's less than 0. Let's choose an easy one, -1. Plug that in. -1 squared plus -1 over -1 minus 5 less than or equal to 3 times -1. When you do this, it's going to eventually become 1 over -6 is less than or equal to -3. Well, that's not the case, so this is not going to be a solution. Second one, second test interval. 0 and 5. Well, let's use x is equal to 1. All right, so I've got 2 times 1 plus 1 over 1 minus 5 is less than or equal to 3 times 1. So I've got 2 plus 1 is 3. 1 minus 5 is -4. Less than or equal to 3. It absolutely is. So this we know is going to be a solution. Next one. All right, so a number that's in between 5 and 16. So we can say x is equal to 10. Let's say our old faithful. 2 times 10 squared plus 10 over 10 minus 5 less than or equal to 3 times 10. When you evaluate that one, you're going to get about 210 over 5 less than or equal to 30, which would give us about 42 is less than or equal to 30. So obviously not a solution set. And then our last one, thank goodness, oops, is number 4. So we're looking for a value that is greater than 16. I chose 20. You can choose whatever you want. 2 times 20 squared plus 20, all divided by 20 minus 5 less than or equal to 3 times 20. So when you evaluate that, it's going to be 820 over 15 less than or equal to 60, and that is about 54.7, which, yes, is going to work. So that is also a solution. So now you can see why some students really don't like this section. It is a little bit of work to actually come up with the solutions, but unfortunately, guys, this is the necessary evil. You've got to do this. So we're going to simplify everything, write out our solution. So that means that here we want to look, we can use, oops, as I cover it up, x is less than or equal to means that we can use closed circles. So that means that I've got closed circles on my, right here. Now, some of you might be tempted to put a closed circle on that 5. I'm going to draw your attention to this guy here. Don't forget that x cannot be equal to 5. So we have to have an open circle there. And then we can obviously have our closed circle on 16. So just be really careful about those non-permissible values, that we definitely cannot include them. Now our solution set has to lie in between these guys, and then obviously from there on. So we can say from 0 with a closed bracket up to 5 with an open, and then union 16 with a closed bracket up to infinity with an open bracket. And that would be our final solution. So a little bit of work there, a little bit of time consuming, but not difficult math, right? It's pretty straightforward. All right, now we're going to finish up inequalities. We've just got a couple more little sections here. This one is saying the absolute value inequalities. So just remember what an absolute value is. It basically, if I take the absolute value of something, I'm always looking at the positive of it. So that means, like, if we look at this example here, the absolute value of x is 5. That means that x could be equal to 5, obviously, or x could be equal to negative 5, because the absolute value of negative 5 is still 5. So how do we solve these equations? We've put them in inequalities because it's not necessarily going to be equal to one specific answer. We have to address situation number 1 and situation number 2. So what that means is I'll just literally call it number 1. 2x minus 4 definitely could be equal to 6, or we could also have negative 2x minus 4 is equal to 6. Those could be our two possibilities. And what we actually have to do is solve each of them. So let's go ahead and do that. Again, it's pretty basic math. Just going to add 4 to both sides, divide by 2, so we get x is equal to 5. And then in this one, we've obviously got negative 2x plus 4 is equal to 6. So we're going to subtract 4 from both sides, and then divide by negative 2, so we get x is equal to negative 1. Now the kicker is that you have to check your answers here. Just like what we did, now rest assured we don't have to do test intervals, but we do need to check to see which ones are actually going to work if we put it back in our equation. So remember our equation, 2x minus 4 is equal to 6, so the absolute value. So let's do that. I'm going to take number 1, so 2 times 5 minus 4 is equal to 6. Well, yeah, 2 times 5 is 10. 10 minus 4 is 6. So the absolute value of 6 is 6, so we're good to go on that one. Next one, 2x minus 4 is equal to 6. That one's going to become 2 times negative 1 minus 4 is equal to 6. Well, 2 times negative 1 is negative 2, and negative 2 minus 4 is negative 6. The absolute value of negative 6 is indeed 6. So therefore, both of our solutions actually do work. So all we have to do here is just say, so x is equal to negative 1 and positive 5. We don't have to worry about those intervals that we were doing before, which is kind of nice. And the last page here, guys, just a little bit of practice now combining things. So I've got inequalities, I've got absolute values, and we're putting it all together. And again, sometimes it might help to visualize what the graph would look like, but otherwise we can just kind of take a look at our test intervals. So I've got x plus 1 is less than 5. So I need to take the first one. X plus 1 is less than 5. And I also need to take the second one. Negative x minus 1 is less than 5, basically taking the negative of that. Solving, minus 1, x is less than 4. And in this case, I'm going to add 1 to both sides. And then this one always gets students. Remember what we talked about a little while ago? If I have to divide by that negative 1, I flip my sign and I get my answer. So in this case, guys, we've got actually, because we've solved each of them individually, we've got our answers where we don't need to use our test intervals. X is less than 4 and x is greater than negative 6. So these are our critical values I know that they're open circles, and x is less than 4, but x is bigger than negative 6. So our answer is going to be lying in there. And if I want to do that in interval notation, it would look just like that. Again, you can pause it if you want to try the next one. Otherwise, I'm going to do it here. So we want to isolate our variable. So there's a couple ways of doing it. You could move the 3 over, or you could just solve it as is. So you can just say, okay, x minus 4 minus 3 is less than or equal to 0. And then negative x plus 4 minus 3 is less than or equal to 0. Then simplify. X minus 7 is less than or equal to 0, so x has to be less than or equal to positive 7. I've got positive 4 minus 3, so negative x plus 1 is less than or equal to 0. Now minus 1, and then divide by negative 1. Boop, flip that sign, so x is greater than or equal to positive 1. So on my number line, I've got a 1 and I've got a 7. That means that x is bigger than 7 or equal to 7. Oh, I lie. It's the other way around. Sorry. Getting my signs mixed up here. X is less than positive 7 or equal to, and x is bigger than 1. So I've got a closed circle, and again, my solution is going to lie right in the middle. And in this case, now I can use the closed brackets, and that would be my final answer. So that was a long lesson, guys. You can move on to the next one, or just make sure that you're always practicing what we've done in each one.